Assalamu alaikum wa rahmatullahi wa barakatuhu. So soil water is the almost the last part in our midterm examination course, and we'll finish here. This is very brief lecture, just telling that what are the different types of soil water and what is soil water potential, and how can we differentiate different types of water considering the soil water potential. The availability of water in the soil is essential for plant growth, of course, it's very clear. Uh, Essential to microorganisms that grow in the soil and they decompose organic matter. Then it is important uh, in the weathering process during the soil formation. And involves the breakdown of rocks and minerals to form soil and release plant nutrients. Water is also a solvent that, together with the dissolved nutrients, make up the solution from which plant absorb nutrients. So, whenever we are adding fertilizer or indigenous micronutrients or macronutrients present in the soil, so they cannot be taken up by the plants unless they are dissolved in the water. So, plants can only take in that case. Control over both soil air and soil temperature because the amount of water in the soil that determine that how much air is there and what is the soil temperature. The force of gravity causes water to move downward through the soil, particularly in the large pores. तो जो फोर्स है जो वाटर को नीचे की तरफ लीच करवा रही, so that is force of gravity. And as in the capillaries or in the micropores, water is strongly held with the soil particles, so the macropores are mainly responsible for downward movement of water due to gravity. Soil water can be classified in four terms. The first one, that is the gravitational water, then field capacity, uh, then permanent wilting points, then plant available water. So these are basically the four terms which are used to classify the different types of water which is present in the soil. Looking at the gravitational water, water present in excess of field capacity or water held at a potential greater than minus 33 kilopascal is called gravitational water. Uh, this Pascal, that is basically potential, we will discuss later on. Uh, it is available as it moves through the plant roots if adequate aeration is maintained. It is of limited use to plants as it is present in the soil only for short period of time. It can affect the plant growth due to poor aeration. So this gravitational water, basically plants cannot take up much from that because it moves very fastly and only uh, in the soil for a limited period of time. So plants cannot uh, take up this water. And the second reason, that is the aeration, because when there is a water, excess water in the soil, that will also fill the pores, so there will be no air. So it means the plant growth has already stressed, and then the utility of that water is also lesser. The second term which you use, that is field capacity. Field capacity mean when your gravitational water has already moved on from the root zone, then the remaining amount of water in the soil, that is called as 100% field capacity. It means when you apply or irrigate the field, after few hours the gravitational water will move down, mean out of the root zone, and then the remaining uh, water in the field are in the above soil layers, so that is at field capacity. Of course, it depends. If you have sandy soil, it will leach down, uh, the gravitational water leach down very easily. But if it's clay soil, of course, it will take more time. And then you can see in the figure the saturation. It means when there is a gravitational water, your soil is fully saturated. So when this water is readily drained, means this gravitational water is drained, so then there is a field capacity. And then there is a term which is MAD, management allowed depletion. Mean uh, the management, while managing water, you can uh, deplete up till now, up till this stage, but not below that. It means that is around about 40 to 60, 50% available water content, AWC, that is available water content. So it means up to 50% you can allow the water be depleted, but the best is that if it's about 60%. And it means this soil water deficit shows that this is the amount of water which we have to manage. For example, when we apply irrigation, the readily drained water is out. Then we have field capacity, then plant will take up water. Some water of course will be evaporated, and then up till this lower side, up till here, so we can or we must irrigate again to the field. But we can go up to here MAD. This is basically a margin that we can do. But if we will go below, so then it will cause stress to the plant. Of course, it is available, but it will have stress to the plants as well. So then we have a permanent wilting point. Permanent wilting point we'll discuss later on. Here I want to just mention in this slide that the field capacity is the amount of water when your gravitational water has moved on. Permanent wilting point is the amount of soil water at which growing plants will wilt and not recover when placed in a humid chamber. So this term shows permanent wilting points. It is not relevant directly if we look at the title to the amount of water in the soil. It is the amount of water. It is that point basically when the amount of water in the soil is as less that the plants are wilted and they will not recover if you apply water to those plants. So that is basically permanent wilting point. The amount of water where the plants, the amount of water where the plants are not able to get water and they are wilted, and wilted so drastically that they cannot recover when you apply water to that. So it means this is a very less amount of water, and we say that is a kind of a hygroscopic water, so which is tightly bound to the soil particles and it's not easily available to the plants. Then we have a plant available water. Of course, when the gravitational water is moved on and the field capacity is achieved here, this capillary water basically, so that is plant available water. The amount of water between permanent wilting point and gravitational water. So this is field capacity as mentioned here. This is permanent wilting point, and this is plant available water, because we'll see in the next slide that we can also indicate it in the form of water potential. But the simple way is that when the gravitational is water is moved down, then the remaining water is plant available water until the permanent wilting point is achieved. कि उसमें से पानी इतना अब्जॉर्ब कर लिया, प्लांट ने टेकअप कर लिया कि जो बाकी अमाउंट रह गई है वो वहां से प्लांट के लिए इतना मुश्किल है पानी अचीव करना या उसके एक्सट्रैक्ट करना कि वो wilt हो जाएगा and will not recover. So that is basically the permanent wilting point. So those were the four types or terms which we used. Know the soil water potential, because the amount of water and water potential is something two different things. Because potential is that the uh, uh, generally when the plant take up water, so water pass through the cell membranes. So, so we have water, but if that is very salty water and high concentration of salts are there, so that water has very low potential to move or to pass through that membrane. So that's why this water is very important. This water potential is very important. And secondly, if the water is there in the soil, but it is strongly bound to the soil particle, so it means that soil has very low water potential. So amount of water is there, but that is at very low potential that plant cannot take up. The difference between the free energy of soil water and that of pure free water in standard reference state is known as soil water potential. Because we know when the water is free, there is no force on that. So that is basically standard reference state. But when that water is in the soil and that there are forces uh, which are acting on that water, so the remaining energy is less than that of standard water. The free energy is less. Overall, standard state means standard reference state means that is the free energy of that water. But when that water is in the soil, so there are forces of the soil particles, which has some adhesive forces for that. And then if you have salt there, so that has also some forces which is reducing the free energy of that water. So difference between the water in the soil and the standard reference state, so that is basically water potential. The soil water potential can be expressed in bars, atmospheres, or in kilopascals. So generally we use. So we have discussed that we have basically three types of water. That first one, that is gravitational water. Then we have plant available water and hygroscopic water. And we have two terms which we use, that is field capacity and permanent wilting point. So this is uh, a point where there is a field capacity, and above that, that is basically gravitational water. So when the water potential is more than minus 10 to minus 33, because for some soils it's minus 10, and for some soils it's minus 33, or in between, depending on the texture or amount of sand and the clay. And this above water, that has water potential greater than uh, minus 10. So it means that is the water which will be drained out very easily or very swiftly. So that is basically gravitational water. Then start the plant available water, and that water is basically between permanent wilting point. This is permanent wilting point, and the water potential at this stage is minus 15 kilopascal. And this amount of water which is present between minus 15 and minus 1, so that is plant available water. And below that, if water has a very less potential, it means that is strongly bound to the soil particles, or there are solutes in that water, and the plant or the potential is minus 15, 100 kilopascal or below that. So that water is basically hygroscopic water, and this not plant available water. And even when this hydroscopic water is drained out through evaporation or oven drying, so that then the dry soil. So when there is a gravitational water in the field, that is saturated soil. When that is removed or leached down, then we have a field capacity level. If field capacity and of course the water potential, that is minus 10 to minus 13 kilopascal. And if we have a less than that, uh, then it is plant available water up to minus 1500 kilopascal, and below that we have hydroscopic water. So coming to the last point, soil temperature. uh, Soil temperature of a soil influences plant growth and crop yields, of course, because all the chemical reactions, and even if there's some more heat and high temperature, it will also have some physical stress on the plants, plant roots as well, and plants influence date of planting, because we have to sow the seeds or the seedlings, so it will affect the germination. Number of days for a crop mature. If we have a high temperature than the normal temperature, so then of course it will be matured early. It is a almost thumb rule that when you have any kind of stress to the plant, so they will try to complete their reproductive cycle. So when there is a temperature, high temperature, the plant will try to complete their reproductive cycle as early as possible, if other things they are available. So that basically stimulate the plants to mature early when you have some kind of stress on the plant. Subsoil temperature is less variable than the air and surface soil temperatures, because the subsoil temperature is not directly relevant to the are related to or in concern with the atmospheric temperature, so that is not much affected. The average annual soil temperature can be approximated by adding about 2 Fahrenheit to the mean annual air temperature. So soil temperature is relatively, if we take the average, so that is 2 Fahrenheit more than the air temperature. Uh, of course, in arid sunny regions, so that is even more than 2 Fahrenheit. Factors influencing heat absorption include soil color, water contents, mulches, vegetative cover, and soil slope, as well as its direction. Slope mean how mean the height or the angle of slope, how much is that. If it's very slopy and it's in the direction of sun, so of course that will affect the temperature. Soil color, if we have a darker color, it will absorb more light, more rays, heat rays, and then the temperature will go higher. Water content, if we have less water content, it will raise the temperature as early as more early as compared to soil color. And then we have mulches. If we have some kind of artificial or natural mulches, it will also reduce the temperature. Vegetation cover that will also reduce the temperature. So temperature is also very important in crop production when you are going for agriculture crop production, especially. uh, and we have to take care of that. We can reduce it as mentioned here by use of mulches, and we if we have a always cover soil cover through different kind of vegetation, it means the soil is not bare, so that will also have some positive impact. So thank you very much.